All right, day 31. Last day we were solving some exponential equations algebraically. We're going to continue on with that a little bit today, um, but the textbook refers to this section 4.4 as points of intersection. And we've kind of done this already earlier when we were solving exponential equations graphically. We're going at it again, but they're a little bit more difficult problems. We'll see. The 3-minute review starting with a question straight out of yesterday's homework where we got to write both sides with a common base, and we see 27 is a power of 3, so we can do this exactly without using a calculator. The bit 27 as a power of 3 is 3 to the exponent 3, but since it's the square root of that, remember the number on the bottom is 2 then, and then I can make the exponents the same. Cross multiply, grade 9 equation. 6 goes on the other side here. X is 6. Use a graphing calculator and the intersect feature to solve this equation of this equation. We did this the other day. This isn't the right one here. Let me go y equals, and then I'm going to put 2 to the exponent x in one side, and then the other side I put 20. And delete all. I should have pressed clear so I got all that other crud off there, but 20. And then my window settings, I don't know. Certainly not this much. Maybe, x is 4. 2 to the exponent 4 is 16. 2 to the exponent 5 is 32. So I know it's going to be between 4 and 5. So if x max is 6, that should be lots. Go up by ones. Go up to 20 or 25 should be tons. Maybe I'll go up by 5s this time. Then I press graph. There's my 2 to the exponent x. Looks nice. Remember, these are going up by 5s. 5, 10, 15, there's 20. There's the intersection. I get to it by going second trace to get to the calc menu. Hit 5, follow the online instructions, the on-screen instructions, first curve, second curve, and the guess. And you probably figured out you don't have to get very close to get the to get it to find the intersection. X is 4.3 about, and I'm gonna paste that in there. You normally copy your sketch in there, or do a sketch real quick to show that you did it right. But fantastic. Essentially, today's stuff is combining these two types of questions. We're going to do this type of question on the calculator. So look at there, example 1. Use the graphing calculator to check your work from number 1 from the 3-minute review. Well, this shouldn't be much harder than the one we just did, right? Except for we just want to put in the y1 and y2, the left side and the right side. That is a little more difficult. And I think we might have even already done one like this. 3 to the exponent. In brackets, I'm going to put my exponent 2x minus 3. And in here, I'm going to put the square root of 27 to the exponent x. And I mean, if you can't find the square root key, well, there's the square root there. See it? But I could have put 27 to the exponent x over 2 if I wanted to, right? But I'm going to try and put this in exactly as it appears. 27, right? 27 to the exponent x. And I don't know where these are going to cross. Well, actually I do, because we did it in number 1. It's going to cross at 6. But if I didn't, I might be tempted just to hit this graph with using whatever window settings I've got. And hopefully I see some of my graph. There's one taken off. There's the other taking off. And notice they look like they're going up at the same rate, but I'm going to have to expand my window settings, right? So I'm going to make this go way out. 10 or 12, and I'm going to make this go way up because it could be quite high. Maybe I'll go up all the way up to 1,000, so I make sure I get the intersection on here. Let's have a look. Remember, these are going up by hundreds now. Oh, getting close, but I still got to go up. I still got to make this bigger, so change my window settings again, maybe 5,000. Maybe my X max. It looks like it's going to cross before 10. I'm going to go back a little bit, just change this a little bit. Maybe I'll even go out to 50,000 just to make sure I know where they'll cross. And I'm going to go, my scale is going to go up by 10,000, not by 1,000. So each of these ticks is 10,000 now. Oh, there I see the crossing point, but it's really hard to read that. But do I care really? Not really, because I'm going to use my intersect feature, right? First curve, second curve, and the guess, well, doesn't really matter, right? Because it's going to skip to the right answer anyway. It's going to skip to the crossing spot. I hope it's working. Right there, x equals 6. And so again, you're going to copy that graph onto your note. And I'm actually going to this time also put this so we can see that. So you just so I know what you put into y1 and y2 to get the intersection. Okay. So you copy these two things and then a concluding statement. So therefore x is 6. All right. Good. What's next? Use the graphing calculator to show that the equation has no solutions. And again, let's try this. 4 to the exponent, left side and right side here, 3x minus 4. And again, if you think about it, I'm kind of worried about this because last time it looked like the sketches never had a crossing point, right? But because when I press graph and whatever window settings that I've got, and maybe I want to zoom way out so I get an idea of what these graphs look like. There's one. There's the other. See, they look like they're going up by exactly. See how the little lines are in the same spot. I'm guessing that they're not going to cross. But let's maybe try it. Just see what happens. First curve, second curve, and a guess. Well, I'm just going to press enter and see what the thing does. It should break or something. Maybe the calculator will blow up because we know it's got no solutions. It said error, no sign change. So the graph looks like it's just asking us to quit. The graph looks like there's no crossing spot. So the sketch would be, here's my window. And this one, we say the graphs appear to increase at the same rate. Sorry about my handwriting. This is getting better and better all the time, isn't it? Increase at the same rate. The intersect feature, sorry, gives us an error. No solutions. Okay. Use algebra to show that the equation has no solutions. We actually saw one like this the other day. How I would solve this using algebra is I'd want to write both sides with the same base and then see if I can get the exponents to equal then. and I see both of these are both powers of 2, so I should be able to do this. This is 2 squared, this is 2 cubed, the exponents are equal, and what happens is then I get the same coefficient of x on both sides, and when we subtract, you know, it disappears. Subtract 6x from both sides and I get something stupid. Minus 8 equals 3. Well, minus 8 isn't equal to 3, is it? This is impossible, no solutions. Okay, I'm going to stop the video and we'll do part 2 in just a moment.